So today we'll be doing something quite interesting. I haven't done this before the stream, so I'm doing it live. But today we'll be doing a Wordle board. So yeah, recently there have been some posts so there's this game called Wordle, and basically someone has told me if you look at this three blue one brown, he has done something like solving Wordle using information theory. So yeah, something like this. Let's try to code out something like this. Uh, I may not use information theory in the end. It's a nice idea, but we can try other methods as well. Yeah. So yeah, we don't need to limit ourselves to this. So firstly, just to let you all see like how you can actually get the. I hope you can see it, the like words out. You can just go to like this the inspect element, and then I actually learned this from one blog post. So yeah, you can actually inspect the element, and then you can actually go to what's the search button for this. Yeah, but basically you can actually get the the, the word list if you just inspect element and you search for something. Okay, I not sure why it's not searching here. Okay, maybe you have to use Google. Yeah, I mean, I use Google inspect element and actually went to get it out. So the word list is here already. Okay, so this is like 12,000 over words, and yeah, so I just put them into one. Oops. Uh oh. Oh no, what did I do? Yeah. So actually, there are also people who have done like something like what do you call that? Uh, Reinforcement learning methods. So that could be like done in the future as well. Okay, let's see what's wrong with my Jupyter Lab. Okay, after I did a backspace, it apparently didn't work out anymore. So, oh, okay, I hope this works. Okay, because, yes, okay. So, desktop, Wordle. Okay, so we have this word string. So, firstly, we just have to get the words out. So, we can do a split, okay, and we can split by comma, okay. So we can actually see the words now. The words are like that. Okay. Okay. So there's still a comma here, but the words essentially is this double letter thing. So one thing we could do is we could actually remove away all the apostrophes. So how do we do this? Is we can actually just do a remove character in string. So if you want to remove that character in string, we can do a replace method. Okay, and then the replace method will replace a character with a new character, and this will be done like I believe all the time. So let's see, word string equals to word string dot replace. Okay, we replace this with a now character. Okay, great. So now if we look at all the words here, we do a word 0, that will be Siga. Okay, if we do a words 1, this will be rebuts, and so on. So if let's say we want to find the character for this, like this will be S. Okay, this one will be I, and so on. Yeah, so we can actually get all the characters out already. So we have created like our words. Let's see the length of these words. 12972. Let's just print this out. There are, okay, we do a F sprint. There are how many lang words, Wordle words out there? Okay, so I am not too keen to just filter the list based on uh like how the actual Wordle did it. They actually have their own word list. Actually, I haven't done today's Wordle, so we leave it as an exercise. Okay, I mean, like later we just see whether we can get the bots to solve Wordle. Okay, so now we will just try to use this entire 12972. Okay, so now we need to code the interface. I haven't done this before, so let's see, coding the interface, the game interface. Okay, let's code out our game interface here. Okay, let's see how to code it. Okay, so how do I do this? We need to have a target word. So we have a target word equals to np. Okay, let's import np. Import numpy as np. Now np dot random dot choice words. Okay, then let's print target word. Okay, so this will give us, I believe, I'm not wrong, this should random sample the array, and then this will give us a random word. Oh, that's great. Okay, so we have a random word here. Okay, so we print this random word. Okay, so now you can see like the word is frank, the word is good. Okay, so now that we have a target word, okay, we want to basically do some form of matching with the guess. Okay, so how do we do this? All right, so we have a guess. Okay, let's see. Okay, okay, define guess word. Okay, so word and target word. Okay, so actually we shouldn't have a target word here. So let's have this. So this function takes in a word as well as the, okay, I think we still need a target word. Takes in a guess as well as a target word and returns the positions of returns an array of 0, 1, 2, signifying 5 positions of, signifying, I guess Wordle has the gray, the whites, yellow, green, right? Yeah, so let's do that. Okay, so we have this. Okay, so we have to do some form of like something similar to Minesweeper, I guess. Sorry, not Minesweeper, for Mastermind. Yeah, so probably what we need to do is to find out for the word and the target word, like to see what is okay. So let us see how to do this. Okay, so okay, let's see the guess outcome. Let's just call it outcome. Outcome equals to 0, 0, 0, 0, 0. Okay, so for I in length, okay, so I guess we need to have an array to signify whether or not the letter has been guessed. Okay, so for I in length range, actually it's 5, right? We already know the word has 5 characters. Yeah, so if word I equals to target word I, if it's the same word, okay, then we will just put outcome I equals to 2. Okay, so this will do the green guesses. Correct position, correct position, correct letter. And this will do the yellow guesses. Okay, so I think I will need to have another copy of this word here. So it's like because I don't want to like modify this actual word, because if we do the word modification directly, I'm afraid that it might be like it modify the actual input that I pass into this function. Okay, so this is correct position, sorry, correct letter, wrong position, correct letter. Okay, the outcome I is 2, and also we delete away the my word I, so we call this my word I equals to, okay, if the outcome is 2, okay, my word I will be equals to a blank. Yeah, yeah, actually what we can do is like that, we can do a list word. Yeah, then we can immediately store it as a list. So if this is like that, this will be a blank. Okay, let's just return outcome first. I just want to see whether this kind of works first. So guess word table target word. Okay, so let's see what's the target word. The target word is LB. So if we do LB, this should be 22222. Okay, so it looks like it has gotten like B and E correct because the target word is LB, which is exactly what we want to do. So now we want to do the wrong position correct letter ones. So how do we do this? For I in range 5, okay, if my word I, okay, in the target word, okay, which means that it is inside this thing here, that there is such a letter in the target word, okay, then the outcome I will be equals to 1 because that's the wrong position. And then we also need to remove the word. So my word I equals to blank. Okay, if I do this, then if I have two E's, the second E, I also need to remove that thing in the target word actually. So let me see. Yeah, looks like I need to remove both sides. So after we do a match, we need to sort of remove that word so that we, okay, if my word I in target word, if my word I is not a blank and I get my word I in target word. Okay, so actually we can just use word, I guess, because if we do both as a list, then it will not take the same memory space. We can potentially do this. Okay, this will do the yellow gases. I think this will do the yellow gases. So this, and the last one will be, this will do the green. Actually, we don't need the last one, right? Because if it's not a green or yellow, it will be default will be the white ones. So let's see whether this works. Okay, so table, okay, 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 that's kind of weird. Okay, we shouldn't get like all. Okay, let's give a blank word. Okay, something's wrong with this. Oh, no wonder I did wrongly. This should be target word rather than word. Okay, so this should give me 0. So the word is pleon, so pleon should give me 2. And if I put like pants, P 2, correct? A, this not here. N is incorrect position, correct? PS, this doesn't have. So if I were to do like P N, only the first N should be, oh yeah, correct, because of this, but this is correct. Okay, how about P N T? Only the first N, okay, should give me a 1, and the subsequent N should not. Okay, so let's see. If word I is word I in, oh, okay, I get it. Okay, we need to find out like where is the target word here. So okay, so we sort of need to do like for J in range 5. This is a very, it's not exactly that great in terms of optimization. If word, yeah, so only when this is like that, if word I equals to target word J, okay, then we do the outcome like that. Outcome 1 is 1, target word J, yeah, so we need to sort of like loop through this another for loop. Okay, if target word not, So we can actually do a not equals this one, and so that we limit away some of the possibilities like that. So now the target word is recap. So recap will be like that. Rep, okay. REACP will be, yes, correct. These two will be opposite. So recap will be like that. REAAP. Okay, good. Good. How about this? AAAPA. So only the first A, okay, will be given as one, and only the next, the first P will be given as one. So if we were to put like AAPPA, we only get 10100, which is good because we don't want the letter to appear to be given the same clue twice. Yeah. Okay, so I think we have gotten the guess word function correctly. So now we need to define the game loop. So maybe I, instead of calling the game interface, I'll just call this doing guess function. Okay. So maybe what I do here is coding the game interfaces here. Yeah. Okay. That looks good. Yeah. It's like polio. See POL. So that this is the P's here is in yellow. So maybe what I will do is I also want to display the word guess over here. So let's display the so define display word. Okay, and then we put word and let's call this guesses outcome. I will just call this outcome. Okay, word and outcome. Okay, so this function takes in the word and the guess outcome and outputs a grid. Okay, and outputs a grid of boxes with color. So to do that, we're gonna use plus SPD. Okay, then okay, let's just see. Oh, okay. It's not pandas. Oh, Seaborn. Sorry, Seaborn. Yeah, Seaborn. Must pass 2D inputs. List them. Okay, Seaborn. Yeah. Okay, actually, I think I can see over here. So if I were to display on a heat map, a rectangular data set, okay, format. Mm, is there a way to put labels inside here? Data and I just want to create the color printing. A heat map is great, Maybe instead of doing it for the word, we just use the outcome. Okay. Oops, I forgot to import. Okay, so this isn't that great. Uh, I mean, I guess everything failed, right? Everything's a zero. But I want the heat map to show distinct boxes. So let's see. C bar equals to false. I don't need the color bar. Okay. Square equals to true, I guess. Square. Okay, that looks good. Axis. I don't need the axis. So what's the axis? Ax equals to none. Okay, let's see how to remove axis from heat map. I don't want to display the axis actually. Okay, I guess I can do x tick label and y tick labels equals to false. Oh, great. Okay, then now I need a gap in between the. Okay, I need a gap in between the heat map. Yeah, I want something like this. I want a heat map with gaps. So let's see. Something like this. Line width. Great. Line width. Line width equals to 1. Line color equals to white. Okay, very good. So now we have the list of outcomes. Okay. So if let's say we have Rocky. Okay, all the we should put like v min equals to 0, v max equals to 2. Okay, so somehow the outcome, oh, because I didn't do the guesswork. Okay, so let's see. Okay, so now we have some different colors here. So that's great. Okay, we just need to now change the color of the heat map colors. Okay, because we want the heat map to have C map. Okay, so let's try C map equals to, okay, the whites, or gray maybe. Gray for nothing, yellow and green, right? Okay, good. So now this looks, okay, so this looks quite nice already. Now we need to annotate the letters. So uh, I like heat map because like it draws all this automatically for you. If not, you can have to use like matplotlib to do it one by one. Yeah, this is like a wrapper over matplotlib. Okay, C map center robust mode and not. I need to do some annotation. Okay, so we just need to do another annots equals to list word, and because it needs to be a 2D list, we need to do it like that. Oh, format equals to string. Net with custom text. Okay, so I guess my format need to be a blank. Oh, great. Okay, good, good, good. So, okay, I think because in Wordle your letters are capital, right? We want to make it capital as well. So let's make it capital. So how do we do the capital? We can just do it over here. So we can do like that word string, uh, dot to upper, dot upper. Display word. We will guess. Okay, so this one we can put it at the top. Okay, we can shift it one cell up like that. Okay, outcome and then display word. Word. Okay, guess and outcome. So my guess will be like nice. I mean, we can try something nice like slate. People like to use this. Oh, not bad. Slate gives you this. It's pretty nice. One thing I would like to do is to make the annotation size a bit bigger. So, uh, how do I do this? Make annotations size larger in bitmap. Okay, we have this. 20. Yeah, there we go. There we go. 30. Oh yeah, this looks good. This looks good. Oh, nice. All right. So now what we want to do is we want to basically do some form of interfacing, okay, with the human player. So it will be like this. Okay. So I guess we can also not just display like the guess itself. We can also maintain a like here is a list of outcomes. Okay. What we want to do is we want to actually instead of doing this, okay, we want to actually do the annotation here ourselves. So we can do this. Okay, let's we have MP here, right? So we can do mp.array guess, okay, dot reshape -15, okay. Then we can also do here mp.array get an outcome dot reshape, okay, so that we can like oh okay, so we can actually have like guesses equals to like that guesses dot append, okay, list guess, okay, and okay, and then we can actually do Actually, in this case, we don't even need this. As long as we do this, I think when we display guesses and word and outcomes, we should be able to get the entire list out. Let's pass 2D input. Print guesses. Let's see. It is a 2D input, isn't it? Yeah, okay. Looks like it's okay. So if I were to like delete away this line here, we can form like multiple columns of our guesses like this, like the normal Wordle style that we see in this thing here. Yeah, very nice. Yeah, okay. And I mean all the guesses look different because the target word is always different. So you can see actually slate not bad. I mean most of the words, it seems like it has some form of, it looks like it's being able to match quite a lot of samples, I guess. Yeah, so this is not bad. Okay, so I think this is not too bad already. Okay, we can just delete all this. Okay, though. Okay, print target word is target word. Use a F prints like that. Okay, yeah, not bad, not bad. Yeah. Okay, so now for coding the game interface. Okay, while guess not equals to. Okay, so we have num guesses equals 0. While guess not equals to target word. Okay, so what we need to do is we need to do a target word like that. Okay, if a random target word. Okay, while guess not equals to target word and okay num guesses is less than 6. Okay, because we only have 6 guesses. Okay, at the end we will need to add 1 to the num guesses. Okay, so guess equals to input, key in your guess. Okay, so this will be the game interface, and then after that what we'll do is we'll then use something like that, guesses and outcomes like that, guesses outcomes, put it here. Okay, generate. Okay, so while the guess is not the same as the target word. Okay, so at first we will just put guess as a blank. Okay, our guess not equals to target word and the num guesses is smaller than 6, which means that we only have 6 guesses. I mean like the normal word again. Okay, then we will then just put key in your guess, I guess, then you can. Okay, so what we want to do now is, okay, let me just delete away all this here because it's too much. Okay, I mean this is a nice video if you haven't watched it yet. Yeah, so we try to do something like this in the end, hopefully. Okay, so let's see. After we key in your guess, we need to make sure that the guess is in the list of words, right? So okay, so firstly what we need to do is we need to get a new list of valid words or words remaining equals to copy words. Okay, we do a copy of the words. Okay, if guess not guess dot upper not in words. Okay, actually we should just put like wow guess dot upper not in words. Not a valid word. Enter another word. Okay, so only when it's a valid word, okay, then we do, okay, do the game interface code, do the check of words. Okay, so we can just copy this, I guess. I mean, with the exception that we don't do this. Okay, we do this, we check whether the words are there. Okay, guess word, guess, comma target word, guesses dot append list of guess, outcomes dot append list outcome. Okay, looks valid. Then we display this, display the guesses. Okay, then what we want to do is we want to uh, potentially after you key in your word, okay, we refresh the output. So open Jupyter Lab, remove outputs. Let's see how we do this. Keyboard. No, I don't want the keyboard shortcut. In file. IPython.display. This one. So we can just clear output here. Copy is not defined. Okay, we need to import. Module object is not callable. Okay, wait, let me do something. I want the word to be capital. So this will be apple. Let's see. Yes, I mean we can try the e's here. So maybe it will be stew. No, I want to try something different. Shout. Yeah, shout is totally different. Oh, it's either my word is very difficult or it's like doesn't have all the other vowels. There's I haven't tried I yet. Uh, rinse. Route. I don't know. Oh, okay. Let's see. It ends with ed, right? With R. Fair. Okay. So the R is not here. It must be here. There's no A though. Okay, looks like the interface is working well. So after that, the last one will be uh, I think there's a C. Creed. Could it be Creed? CREED. Greed. That could be. I don't think I can solve it, but yeah. Oh, it's Creed. Okay, so I think this is great already. Okay, probably over here. Oops. Over here, I want to like end game interface. Okay, if num guesses, okay, smaller than 6. Okay, print congratulations, you won. Okay, else prints the word was target word. Okay, try better luck next time. Yeah, okay. So let's just like keep king apple for, for 6 times just to see that you will end. Prawn, okay. So looks good. Okay, one thing I would like to do is in this function of display word, okay, if let's say the outcome itself, okay, doesn't have the full list, I want to actually display an empty string. So what we can do is like this. Uh, guesses will be this for I in range 6, okay, will be 0 for, okay, so can I just do this? Okay, I need to do a double loop. Guesses will be this. Okay, so I think what I'll do is I'll do something simpler. I'll just do like that. For I in range 5, okay, and then after that for J in range 6. It's a double loop. So here will be for I in range 5. Okay, okay. Yeah, so that we have all this here. So I think I will have another outcome, okay. Outcome 3, okay, will be white. Oops, maybe not white, but okay, it can be white, I guess. But we will just, it's white, right? Yeah, yeah, we will just put a line color as black. Or line color can be pink. Nope, 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 doesn't look good. Green, blue, brown. Gray. I think black looks good. Yeah, so we can just copy and paste this guesses here, like that. Okay, and then we can just do this. The num guesses. Yeah, I'm coding the game interface. Okay, I haven't really coded the AI yet, but the AI will actually stem from this game interface. Okay, so this will be like that. Okay, Apple. Okay, good. So okay, so maybe what I'll do is, okay, I want to basically do the clear output. Maybe I'll display the guesses earlier. So what I'll do is, okay, I know what to do. I'll clear the output here first. Okay, and then I will just display the guess here. play the guess one time first. Okay, then we have the guess equals to this. The clear output will be here. Okay, uh, and I don't need display here. Okay, yeah. Okay, so this will be like that. Apple, key in your word. Okay, so there's some issue here. Okay, the issue is that there's this L and E that are like white right now. Okay, not too sure why is that, but let's see. Okay, let's try a word that doesn't exist. Okay, abide. Yeah, somehow the mm, apron. Somehow there's this thing that it's not displaying the outcomes properly. Somehow the outcome is not done properly. Like 00000 leads to all gray. That's correct. Bacon 00020. Okay, I see the problem here. See the problem here. My Vmax is 2. I should be having Vmax as 3 now. Okay, because I have gray, yellow, green, and whites. Okay, apple. Okay, good. Bacon. Okay, so there's a P here. So okay, let's end this. Mango. Can't even think of so many fruit names that salad. I wonder if I can solve this. S something P. Nope. I don't think I can solve it. Yeah. Sipes. Never heard of this word before. Sipes. Sipes. Okay, but anyway, looks like the interface is coded out correctly. Okay, I can just unprint my words, I think. Let's see. Let me unprint my words. Okay, so this interface looks good. Okay, we can then based on this interface, okay, and basically use this interface to train our AI agent, which isn't actually a deep learning agent. I mean, there are some people who use some form of reinforcement learning, like deep Q network or actor critic models to learn this. But the performance wasn't that great also. I think they might have not optimized it properly. Maybe we could do this next time. But the main thing I want to do is a very simple bot that basically just does the uh, minimization of the potential guesses. Okay, for each outcome. Okay, so let us start coding the bot. Okay, so this is my game interface. Okay, so this will be for human players. Okay, okay. So I am quite happy with the interface. Okay, let's just try to solve this. Okay, then we start coding the bot. Okay, so over here, coding the game bot. Okay, okay. So if let's say we want to do this, okay, shouts sp spill. Okay, yeah. Okay, so okay, looks good. So now I'm just going to copy this code here and put it here. Okay, because instead of having the guess, okay, be done from the human player. Okay, what we want to do is we want to let the AI, okay, do it. So what I'm going to add here is I'm going to, instead of having the guess here, okay, we are going to make the guess, okay, be done by the AI. So agent. Let's have the agent. We give it the words remaining, okay, and we give it the guesses, outcomes, and maybe the num guesses. So the agent will take this game state, and then it will print out its guess. Okay, so this will basically mean that the agent will be playing with some states that we give it. Okay, and with those states it can then produce a guess. Okay, let us code the agent then. Okay, find agent. Okay, word remaining. So it's words remaining. Okay, so this words remaining for human, I don't think is necessary because we don't need to know this. I mean, keep the words remaining list in our brains. Okay, yeah, but for the AI, they need to keep this. So assuming that I just this is a stateless AI, stateless agent, the agent will take in the words remaining as it states. Okay, so that basically it knows what are the words remaining. Actually, in terms of the guesses and the outcomes, the only guess and outcome that it needs to take in, actually it doesn't need to even know the guess and the outcome, right? It just needs to know what are the words remaining, what are the potential words remaining based on the filtered list. And from that words remaining, because all the guesses and outcomes are not as crucial. Okay, the only reason why we have this guesses and outcomes are really just to generate the words remaining. Okay, in if we can get the words remaining that can still be guessed, okay, then essentially we don't really need all the state of our guesses and everything. We just need what are the words that are still possible. Okay, so we will do the filtering of the words remaining here. Okay, so okay, check what are the words that are possible. Okay, and then we feed this information to our agent, who will then use whatever heuristics that they want, okay, to then figure out what is uh, the strategy that they need to solve it. Okay, I mean, I guess a more native way of doing the agent will be to feed it the guesses, the outcomes, and then after it will just figure for itself what are the words remaining. I mean, it's possible. I just think that since all the agents are going to do that, we might as well just do it for them. Okay, let's just do it here. Okay, so what are the words that are possible that are still in the list? Okay, so words remaining equals to, okay, okay, so what we want to do is we want to do the guess word of, okay, new words equals to this for each in guess word, for each in for word in words remaining. Okay, for words in words remaining. Okay, okay, if guess word and if it matches, okay, if it's the same, okay, then we add it to our new words. Okay, then at the end of it, we'll just take the new words dot copy as our words remaining. Okay, so maybe what we can do is we can just print length words remaining. Okay, we do a weight equals to true here because it's a AI agent, so we can just print. Okay, there are how many words remaining. Okay, so Okay, of course we need to define the agent. Okay, we haven't done this yet. Okay, so return mp.random dot. We just do a where's my word equals to list word? Where was this from? In guess word. Somehow there's something wrong. Function is not it. Oh no, the kernel seems to have died. Okay, let's okay, let me just run the whole kernel again. Okay, so there seems to be something wrong with coding this part here in the board for the words remaining. But the idea was to just filter down the whole list of words into uh, the words that can still be there. Okay, so let me just finish this game that we have earlier. Apple, 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 apple. Okay, myths. Okay, that's the word. Okay, so mp.random.choice. Okay, let's just print this. Okay, so maybe we can just put like this: guess equals mp.random.choice words remaining. Okay, and we print out the guess. And then we return this guess. Okay, so like that. Why function object is not iterable? Okay, so let's see what is what's remaining. Okay. Oh, okay. Copy a list. Okay, so I guess it's because of this what's remaining. Okay, so if I do a words.copy, I should get the whole list here, which is correct. But then if I do this words remaining here, this looks correct actually. I mean, okay, so the problem is not in this. The problem is probably here, in new words. Okay, I get it, I get it. Okay, new outcome. Oh, actually, I don't need this. I can just do it like that. If the guess word guess is the same as outcome, new words dot append word. That's the problem. Oh, wow. Randomly guessing works. I mean, this was just a random guessing agent. Oh, yeah, actually, water is not that hard after all, right? I mean, yeah, just you're just randomly guessing, right? I didn't even do. I didn't even code anything. I just merely did a random guess of the random possibilities left. Oh, failed. He got it right? Isn't it? Actually, I should just put if guess equals to target word. Okay, so the random agent, oh, not bad. The random agent seems to be able to get some of them correctly. So this was random agent. So this is the random agent. Okay, let me just change this thing here. If guess equals to target word. So let's just try this. Apple. Okay. Fruits. Shout. Apron. Okay. Opera. Okay, let's just end this. Okay. Whatever. Okay. Pago. No idea what this is. Okay, but in the bot. Okay, so this was the bot. Oh, not bad. Trust. So we can actually view the performance of the random agent across all uh, the game itself. So maybe what we can do is we can do this. Okay, define game. Okay, and then we have a target word here. Okay, place a game with the target word. Okay, okay, what does it returns? Returns number of guesses for the word. Okay, and the number of guesses is capped at 6, I guess. Yeah, so okay, so we have this. If we want to do that, we probably don't want to display anything. Yeah, we probably don't want to display. Okay, so input. Okay, target word, 5-letter word. That is the target. Okay, and then the display is whether or not to show the game. Okay, and then we return the number of guesses for the word. Okay, so we define a macro function called game. Okay, that we do this. Okay, and then we have this random agent here. Okay, now this is the random agent. Okay, and then okay, if display. Okay, this one is if display. Then we print this. Okay, and then over here if display, then we print this. Okay, what we need to do, we need to return. Okay, num guesses. Okay, so over here the num guesses we limited it to 6. Okay, but maybe in this case we will not limit this. Okay, we want to see like the average number of guesses, so maybe we put it as 20. Okay, so we will keep looking until the so we return the num guesses like that. Okay, so all we can do is okay, I guess what we want to do is also like agents. Okay, so input. Okay, inputs. Okay, target word, 5-letter word. Okay, this one is a string. Okay, this one is a boolean. Okay, and then we also have an agent. Okay, agent, the agent used for the game. Okay, this one will be an agent function. Okay, so let's say we have a game and then we our target is actually, so over here the agent we just default to be random agent. Okay, game we put as apple. So if we display false, okay, oh okay, I forgot to change this if display. So only when we want to display it and we will show this. somehow I'm still printing out something, so there must be some here. Okay, so only when we want to display, then we display this. Okay, so if we don't display, you can see that with the starting word of Apple, the this is, for your information, this is just the random agent. Okay, so this random agent is really it has no brain. Okay, it cannot say no brain. It just really takes in the sampled list of words, and then it just randomly selects one of them. So there's really no curation here. So you can see that Wordle is not that hard, right? I mean, if you have the whole list of words, you curate the whole list of words, and then you just randomly select the word. Yeah, it seems that you can get performance of within 6 tries. Yeah, it's actually not bad. Yeah, I think it's, oh, okay. So I guess I need another argument. So the argument is max guess. Max guesses is the maximum number of guesses the agent can make. So this will be an integer, and then this one will be max guesses. Yeah, yeah. Not bad, not bad. Posy. Okay, so looks like we have narrowed it down. Okay, we can actually use a random agent pretty well, I feel. Okay, so okay, if we want to display, right? Okay, actually just now the max guesses, the more we have it, the worse the figure size is. So there must be a way to set the width of the Python display. Okay, set width of heat map. Okay, I guess I can set the size here like that. So because this one we can go up to max 20 guesses. So we will have something like 3 times max guesses. I'm not sure, but okay. Okay, so maybe this may not be enough. 10 times max guesses, I guess. Oh, something went wrong here. Okay, hang on. Okay, fixed size matplotlib. See how to adjust the figure size. The figure size is like this, width and height. Okay, so this width can be 8, height will be like this. It's a bit too big for the width, the height as well. It's 5, maybe like that. Okay, so if the num guesses is 6, Okay, let's make it a bit smaller. Yeah, yeah, this is good. This is good. Yeah. Okay, good. Let's say 10. Okay, good. So this is like, let's play a single game. Okay, so the max, I guess, is 6. Okay, if not, the max success will be 20. Okay, agent will be random agent. Okay, agent equals to random agent. Oh, you won. Okay, actually, I realized the target word should not be here. It's actually want it to guess apple. Oh, somehow it oh, not sure why it didn't. Somehow it didn't do this. Like once I change my target word here, it sort of like fails after a while. Hmm. Did I do something with the target word that is different from here? Okay, there's something wrong here. There's something wrong. I'm not displaying the right things. I mean, I'm displaying this thing here, which is quite cool. Okay, but it's not exactly getting the right answer. A cannot be empty. Okay, so somehow the guesses are not updated correctly. So did I do something wrong? I didn't change anything, right? I mean, this was the initial one. Oh, I know why the target word cannot be the target word cannot be small letters. So what we will do is we will just make sure that the target word is capital, like that. Okay, and also if target word not in, okay, I think we don't need to do this. Great. So we have stuff like this. Okay. So this is just a random agent trying to solve it. So my target was Apple. Okay, so what I want to do is I want to do another metric called get score. Okay, so find get evaluate. Okay, so what we do is this function will be we will take in the agents. Okay, over here like that. Okay, this function evaluates our agent. Okay, over all the possible words in as the guess as the answer, and returns average number of guesses. Okay, so we have an evaluate function. Okay, so let's see for word in words, because words is our entire list, right? Words here. Okay, words dot copy for the whole words here. Okay, for word in words. Okay, we evaluate this. So we already have this game here. So game. Okay, target word equals to word. Okay, agent equals to agent. Max guesses. Okay, equals to 20. Display equals to false. Okay, we will do this. Okay, we basically need to look over the whole metric. So num guesses will be equals to 0 here, or we can just put total guesses. Okay, in fact we can even do it for per word, and then we can do an average later, but it's okay, we can just do this. Total guesses plus equals to this. Hello, changing stars, what do you say? Have you ever stepped on a bug on purpose? Or are you talking about bug as in a real life bug? Or computer bug? Yeah, and I normally don't step on bugs unless it is like a mosquito trying to bite me, then I don't mind killing it. Yeah, but if the bug is minding its own business, I generally don't do it. Yeah. Why do you have a aversion to bugs or something? Yeah. Anyway, if you have any questions of what I'm trying to do here, you can just feel free to post in the chat. So far I have spent the last hour or so. Oh yeah, yeah, yeah. I had to step on bugs before. That were annoying me. Yeah. Yeah, but preferably not barefoot. Yeah. If not, I would just use a tissue paper and try to hit it. Yeah. So yes, so far what I've done for the past hour is I've been coding the interface for the game, and so there's a human version of the game like here. Maybe we can try it out. So it basically just sorry, the human one is here. Basically just gets a random word, and then you can just like guess a word here. Yeah. Oh man, I don't remember the details for this, but yeah, it's not a very pleasant experience if you were to have to step on the bug. Yeah. Okay, but anyway, the human interface is like this, so you like can just key in any word. Like my favorite word is arise, and we can do like shouts. That's the next one, or clouds. Yeah. So we have OTE. Okay, so let's make EOTT. Uh, T. Let me try TON. Tones. No. Okay, like that. TE. Yeah. No. Sorry, changing stars. I'm not very interested in the YouTube challenge with bugs. TENO. Yes. I have no idea what tenon is. Projectile made for insertion. Yeah. Okay, but anyway, the game is working. So let's now check our evaluation of our agent. Okay, so return total guesses divided by length words. Okay, prints random agent requires average equals to evaluate agent random agent requires average. Oh yeah, changing style, just saw your comment. Yeah, no worries. Yeah, I'm happy to answer stuff. Okay, random agent requires average. number of guesses. Okay, it's probably taking a while, but yeah, let's I wonder how many how long this whole thing is. Maybe we could just do a TQDM, which is the progress bar next time. Oh wow, random agent sure takes a long while to guess. I mean, I'm not exactly doing a very heavy duty lifting here. I'm just doing essentially a random guess of all possible words. But I guess we evaluate over 12,000 over words, which means that there's a lot of games going on, I guess. We need to keep doing these functions here. Which shows that like if we want to okay, I mean just for a game itself, it might take about 5 seconds, I guess. But if you want to do it over 12,000 games, the random agent seems to be quite bad. Yeah, maybe we should limit the max guesses to six. Okay, so let me just stop this program here first. Okay, we just assume that the max guesses is six. Okay, and then we see. Okay, what is this? Okay, so we kept the guess number of guesses at six. So with 12,000 simulations, 12,000 over words with six guesses possible, it's close to about 80,000 different guesses. Okay, so I mean the majority of the operations will then be to do the checking of the words, to check whether the to basically do this copying operation in the list. Okay, which uh, yeah, I guess one way to basically reduce the runtime is to have this guess word function, okay, stored in the form of array. Okay, then we could just do like a lookup method, okay, to basically find this, and we don't have to do this evaluation all the time to basically like do this guess function because this is a O n squared time. Yeah, so that's one improvement, but I just want to see how long it takes for the random agent to run. It looks like it's taking quite long. Okay, maybe what I'll do is I'll just do for maybe the first 10 words to see how long it takes. Oh, okay, I, okay, okay, 1,000 words. Okay, so actually, I guess 1,000 words will take quite some time already. I mean, I could let the bot run and then see its performance, but what I'm going to do is I'm going to take a, a shortcut. Okay, we just set num words to be 100. Okay, so by right, okay, by right it should be the whole. Okay, so if none, okay, uh, actually I should just make this like len words. Yeah. Okay, so maybe we just put num words as 100. Okay, so that we don't need to evaluate the agent over too much of a data set. Yeah, you see, even 100 takes so long. Yeah, so I guess playing this, okay, so it's about 4.87 across like the first 100 words. Okay, and since it's a random agent, when I run this, I should expect differing performances. Okay, in general, the random agent is not that great. Yeah, because like you can see that it takes a lot of yeah, so it goes about 4.57. Okay, so what we can do next is we can code an agent, okay, that basically does something like information theory method. Okay, we can do something like that. So maybe over here I will just put this section as more advanced agents. Okay, more advanced agents. Okay, so this was a random agent. Okay, let's try something like we try to minimize the potential outcomes of the next guess. Okay, so let's see. So in Wordle, after you guess a word, okay, let's suppose you want to make it such that the number once you guess that word, okay, regardless of the outcome of what can happen for that word, okay, your words remaining, okay, will be as small as possible regardless of the outcome. Okay, so in some sense, it is like flattening the so you want to define minimize worst outcome. So they basically want to have a bot that basically gets the smallest number of words remaining regardless of outcome. Okay, so let's just call this minimize worst outcome. Okay, so we have a list of words called words remaining. I think I will need to do this thing here. Okay, so for word in words remaining, okay, so okay, this agent minimizes, okay, the possible number, the maximum possible number of words that could occur after a guess. So based on the bins of the guesses I have, the bins being like the like for example, if one word is gives you like one yellow here and one green here versus one with one yellow here versus words with two green and one yellow. So based on this, we actually can like minimize the worst possible outcome. Okay, let me just code it out and then maybe it'll be clearer. So for word in words remaining, what I will do is I will basically okay okay so find out the guess outcome. Okay, so actually I will need the okay I don't have the information of the target word, but what I will do is I will basically because the outcome can only be in this list of words. Okay, so this will be like our this will be our guess. Okay, and then our guess outcome will be okay. So I actually need to do something like this. Wow, so is this a double loop? This will take quite some time actually. Okay, okay, so we do have a guess tick. Okay, will be blank. Okay, so guess ticks. Okay, outcome. Okay, so this will be our guesses. Okay, and this one will be our what do you call that? This will be the word that we are guessing next, and this one will be like the potential answers for what we can have. Like then we can basically, if let's say we want to guess apple, okay, then over here will be like based on all the possible words remaining. Okay, what are the possible outcome for my guess? Okay, and then I'll put them in the dictionary. Okay, so this is exactly what we are doing here. Okay, so one way to do this, okay, is to do a guess tick like that. Okay, but because we know that the guesses are either 0, 1, or 2, okay, we can actually omit the dictionary. We can do a lookup straight away. Okay, so we can do like that. Okay, guess tick equals to, okay, 0 for I in, okay, let's not use I, for what in range, uh, in range 3 times 3 times 3 times 3 times 3. So that's 3 to the power 5. 243. There's 243 only. Okay. So the outcome will be guess. Okay. Guess word will be guess word. Okay. Words remaining I. Words remaining J. Okay, so the guess word, the target is at the back here. So based on the word that we have now, and based on the word that we have at the later part, okay, we will then so this first word will be the, maybe it's better if I were to use the convention of my guess word. So where's my guess word? My guess word is word and target word. So word is this and the target word is this. So we look over all possible target words, update the guesses, uh, update the number of words which fall in each category. Okay, so based on the words remaining, okay, we have a guess word, we have a target word, okay, and then basically the guess will be the outcome. Okay, so the outcome itself, okay, will be a list of 5 numbers. Yeah, will be a list of 5 numbers. What we want to do is want to put this outcome, okay, and we want to like sort of map this outcome to a number. So what we'll do is we'll do this, okay. Uh, outcome num equals to outcome 0 times 0 times 3 to the power of 4 is 81, okay, times 81, because we only can get 0 1 2, so we can actually do some form of mapping like that, times that. Okay, 3 to the power of 81 27, sorry, 81 27 9. I mean, I can also use a dictionary, but I think it's more clear this way. Yeah, so like that. So the guess state outcome num, okay, well, we'll just add 1. Okay, so actually guess array, I mean, or guess list. And then we will just take the maximum of this. So max guesses. Okay, so basically we do have another list over here. Max guesses. Okay, let's put max guess list equals to I equals to, okay, same thing, we do the same thing, 0 for in range length words remaining. Okay, so max guess list I. Actually, I don't need this. I can just do like that. Max guess. So what we actually don't even need this max guess list. We can put this as best guess so far is, let's put it as 20,000. Okay, and then the best word so far we put it as nothing. Okay. If max guess is smaller than best max guess, okay, then we do a best max guess is the same as max guess, and then the best word will be equals to words remaining I. Okay, and then we will just return best word. Okay, seems good. Okay, let's see how this works in one game. Okay, let's display a single game. Oh, oh, this was random agent. Okay, I thought this was like, okay, let's call this minimize worst outcome agent. Oh, not bad. For Apple, it required 4 only. So just by minimizing. Okay, maybe what I'll do is I will just print out the list of arrays here. No, actually I don't have an array for this, but yeah, for this we can just print out this, so just to visualize how this is. Okay, so suppose we have a list of words. Okay, let me just print guess list after all this. So suppose we have a list of words, like for example, minimize worst outcome agent, and then the words remaining will be like maybe apple, fruits, apple, fruits, alien, uh, rondo, I don't know, kiwis. Yeah, so you can see that the outcomes for like each of these guesses, like if you guess apple, okay, and then like let's say the fruit, alien, rondo, kiwis are the solutions. Okay, this will be the worst outcome. There'll be a worst outcome of 3. Okay, which is like there will be 3 cases whereby, okay, this is 0 0 0 0, that there'll be like no, like if you guess apple, there will be nothing here, there'll be nothing here, and there'll be nothing here. There'll be 3 outcomes that don't match at all, and 1 outcome that is a full match. Okay, but if you guess like fruits, okay, there's 1 outcome there's no match, 1 outcome there's like a few matches. So these are like, you can treat it as different states of the guesses. And then 1 2 1 1 2 1 1 1 2 1 1 1. So it turns out that if you guess this, like you get 1 1 1 1 1. So based on the guess that is written, you can eliminate down to only like the next word will be the answer. So based on this, okay, okay, so you can see that based on this, they guess is fruits. 1 2 3. So this indeed does give you the best guess. Okay, these are the worst outcomes. Okay, so this is an illustration of how this works. Okay, I'm not gonna print this out. Where's my, yeah. So minimize word outcome list, and then like, oh, what was I supposed to do here? I don't need this. Okay, so let's say the target was apple. Oh, it guessed it 3 tries. Oh, how come it's random for the minimize worst outcome agent? I thought it should be deterministic. Mm, yeah, I thought it should be like quite deterministic, but somehow it looks like it can be random. Like the word is apple, but okay, did I do it wrongly here? I think in the game itself it's still using the random agent. So yeah, so I did it wrongly here. It should be agents. Okay, because random agent does do this random thing. Okay, that sometimes doesn't seem to work out. Okay, but if I use like the minimize worst outcome agent, okay, it's taking a while to come out with the guess, and I think it's because it needs to like go through the entire list of words twice. Yeah, which means that if I can have a function that can approximate this thing so that it can just do a lookup, okay, that will save a lot of computation time, because if not I need to keep doing this guesswork. Okay, but the idea is similar. The idea will be to basically um, use this, okay, and then you do the guess that minimize the worst possible outcome. Okay, the other way to do it will be to use like information theory and maximize the information gain based on the probability of the outcomes happening. So both work in slightly different ways. Quite like the minimize worst outcome one better. I mean, I haven't coded this out before, but I quite like this. It's just now the outcomes here seems to be a little wonky. Like not wonky. This guesswork function itself probably takes very long to run. Okay, because you see now I'm doing a double loop. One loop here and one loop here. So yeah, it isn't exactly that great for computation. I mean, this guesswork is a O n squared timing. It takes 5 times 5 iterations, and then like this is 12,000 over words. This is 12,000 over words. It is very easy. Okay, it's very easy for this outcome to explode inside. So yeah, what you see right now is this is theoretically correct, but practically hard to compute. So yeah, I'll probably end the stream here now. I'll work on it later to see whether I can come up with a better way to code this. Okay, and thanks for watching. Yeah, I'll be continuing doing this Wordle bot, and then we'll see how it works on today's Wordle. All right, okay, see ya.